SpaceX just shattered every launch record in history, putting more rockets into orbit in a single year than entire nations combined. Over 9,000 satellites now circle above us, with 140,000 emergency collision dodges happening in just 6 months. But here's what nobody's talking about. Every success is making space more dangerous. When the company that's winning the race is also creating the crisis, what happens to everyone else trying to use orbit? And more importantly, who's going to clean up the mess? Let's dive right in. Right now, there are over 40,000 tracked objects circling Earth. Sounds manageable, right? But here's the reality check. Only 11,000 of those are working satellites doing their job. The rest? Dead spacecraft, broken rocket stages, and debris from past collisions just drifting through orbit with nowhere to go. And that's just what we can track. Scientists estimate there are millions of smaller fragments, too tiny for our radar systems to detect, but still deadly enough to destroy a multi-million-dollar satellite. So if we can't see most of the danger, how do we avoid it? These objects aren't floating gently like balloons. They're screaming through space at 28,000 kilometers per hour. At that velocity, a paint chip smaller than your fingernail becomes a projectile that can shatter solar panels. A bolt the size of a quarter? It punches through metal like an armor-piercing round. Every single object up there is a potential bullet, and the shooting range just keeps getting more crowded. What happens when there's nowhere left to dodge? 10 years ago, Earth had fewer than 2,000 working satellites in orbit. Today, that number has exploded past 11,000 active satellites, with one company responsible for more than half of them. SpaceX has launched over 9,000 Starlink satellites, with more than 6,000 actively beaming internet down to Earth right now. The company has approval to deploy 12,000 satellites total, but they've filed plans that could push that number to 42,000. That's nearly 4 times the number of satellites humanity has launched in all of history, all from one company. When one player dominates the game this completely, who sets the rules? The collision risk isn't theoretical anymore. In just 6 months, satellites worldwide performed over 140,000 collision avoidance maneuvers. That's more than 700 emergency moves every single day. Satellites burning precious fuel to dodge debris and other spacecraft. Each maneuver uses fuel that can never be replaced. Once a satellite runs dry, it becomes another uncontrolled object drifting through the most valuable real estate humanity has ever accessed. How long before we run out of room to maneuver? But the danger isn't just physical collisions. Modern satellites are ruining our view of the universe. At night, these spacecraft reflect sunlight so strongly they appear as bright streaks across telescope images. Destroying data scientists need to study distant galaxies, detect dangerous asteroids, and understand black holes. Some observatories already lose 30 to 40% of their images to satellite streaks. Future telescopes could lose more than 90% if launch rates keep accelerating. We're gaining internet coverage but losing our ability to see threats coming from deep space. Which one matters more when an asteroid is heading our way? The most dangerous debris is the smallest. Objects under 10 centimeters are nearly impossible to track reliably, yet hundreds of thousands exist. Below that size, millions more. Current tracking systems can't detect them, which means satellites can only dodge what they can see. It's like driving blindfolded through traffic at highway speeds, only reacting to the big trucks while motorcycles and bicycles slip through unnoticed. Every launch adds more invisible threats. When does the collision become inevitable rather than just probable? Some people assume Earth's atmosphere naturally cleans up orbit over time. It does, but the timeline is brutal. At higher altitudes, debris can orbit for 50 to 200 years before finally burning up. At lower altitudes, it still takes 10 to 30 years. Meanwhile, we're adding debris far faster than nature can remove it. The most critical zone is low Earth orbit, roughly 300 to 1,200 kilometers above Earth, where most communication and observation satellites operate. This zone is narrow, irreplaceable, and becoming dangerously crowded. Once it becomes too chaotic to use safely, there's no backup location. What's humanity's plan B? Cleaning up space debris sounds simple until you understand the reality. You can't just send a garbage truck into orbit and start collecting. Each piece of junk travels at a different speed and direction. To capture it, a cleanup spacecraft must match its exact orbit and velocity with millimeter precision. One wrong calculation creates even more debris from the collision. Several experimental missions have tested robotic arms, nets, and drag devices. They work, but only on single objects. Removing thousands of large debris pieces would require hundreds of missions costing billions of dollars. And here's the real problem. Nobody has agreed on who pays for it. When the mess belongs to everyone and no one, who cleans it up? SpaceX isn't slowing down. Before they revolutionized spaceflight, the global record for orbital launches in a single year was about 130 missions across every country combined. That was the absolute limit of what the entire planet could achieve. Then reusable rockets changed everything. In 2023, SpaceX alone launched 96 orbital missions, accounting for over 60% of all launches worldwide. In 2024, they pushed harder, reaching 113 launches and breaking their own record. This year, they've already crossed 70 launches halfway through, on pace to shatter every previous benchmark. One company now launches more rockets than the rest of the world combined. What happens to competition when one player is this far ahead? The secret is reusability. Falcon 9 boosters land after launch and fly again and again. A single booster can now complete 20 missions or more before retirement. Before SpaceX, every rocket was thrown away after one flight, forcing companies to build new rockets from scratch for each launch. A brand new expendable rocket costs $60 to $90 million per mission. By reusing boosters, SpaceX cuts that cost to under $20 million per launch. Each reused flight saves $40 to $70 million compared to traditional rockets. Multiply that by over 100 launches per year, and SpaceX is saving several billion dollars annually. Over the past few years, those savings have exceeded $10 billion compared to old-style launch methods. That's not just profit, that's a competitive advantage no one can match. How do traditional rocket companies compete with that? SpaceX also reuses payload fairings, the protective nose cones covering satellites during launch. Each fairing pair used to cost $6 million and was discarded into the ocean after one use. Now they recover them with ships and nets, reusing them multiple times. Each reused fairing saves millions per mission, adding hundreds of millions in annual savings. This aggressive cost reduction enables SpaceX to launch Starlink satellites at unmatched speed. Each Falcon 9 carries 22 to 24 Starlink satellites per launch, meaning they can deploy hundreds of satellites every month. Some months they launch 2 to 3 Starlink missions per week. But here's the catch. Starlink satellites only last 5 to 7 years. SpaceX must constantly launch replacements while simultaneously expanding the network. This guarantees thousands of future launches, whether we're ready for them or not. Jeff Bezos is trying to follow the same playbook with Amazon's Project Kuiper. Amazon plans to deploy 3,236 satellites to compete directly with Starlink. But there's a critical difference. Amazon doesn't have a reusable orbital rocket yet. They've purchased dozens of launches from other companies using expendable rockets, meaning their cost per satellite is dramatically higher. They can't match SpaceX's launch speed or economics. China is also entering the race with government-backed plans for 10,000 to 13,000 satellites. Europe is building its own multi-billion-dollar secure satellite network. The launch race isn't slowing down, it's accelerating globally. Every new player means more satellites, more debris, and more collision risk. When every country wants its own mega constellation, where does it end? The competition is now focused on cost per kilogram. Before reusability, sending 1 kilogram to low Earth orbit cost $20,000 or more. Falcon 9 reduced that to under $3,000 per kilogram. With Starship, SpaceX is targeting under $200 per kilogram if full reusability becomes operational. If they succeed, satellite launch rates could increase by another order of magnitude. We could see 10 times more satellites launched than today. The economic incentive is overwhelming, but the environmental cost to space hasn't been calculated. SpaceX's success is making space more accessible than ever, but also more dangerous than ever. When winning the race means cluttering the track, who really wins? So here's the uncomfortable truth nobody wants to say out loud. SpaceX is winning the space race by launching faster and cheaper than anyone in history. But that success is turning orbit into a minefield that everyone has to navigate. Over 140,000 collision avoidance maneuvers in 6 months. millions of untrackable debris fragments, and launch rates that could increase tenfold if Starship reaches full reusability. The problem isn't just getting worse, it's accelerating exponentially. When does the cost of accessing space become too high to justify the risk? We're at a critical turning point. The same reusable rocket technology that's democratizing space access is also flooding orbit with objects that will remain dangerous for decades, maybe centuries. No international agreement exists to limit launches, no cleanup system can scale to match the problem, and no single company or country is willing to slow down while competitors race ahead. The economic incentives are too powerful, the strategic advantages too important. We're essentially conducting an uncontrolled experiment with the only orbital space we have, and there's no reset button if things go wrong. The question isn't whether SpaceX should stop launching. The question is whether humanity can develop the tracking systems, cleanup technologies, and international regulations fast enough to prevent orbit from becoming unusable. Right now, we're not even close. What's your take on this? Should there be limits on how many satellites one company can deploy? Or is this just the price of progress? If you found this breakdown valuable, hit that like button and share this video with anyone who cares about the future of space. Drop your thoughts in the comments below because this conversation needs to happen now, not after the crisis becomes irreversible. And if you want to stay updated on space industry developments that actually matter, subscribe to Space Update 24 hours and turn on notifications. We're tracking this story as it unfolds. Thanks for watching, and I'll see you in the next one.